I welcome you all to the session of engine system and performance, and in today's lecture we shall discuss about the transistors and then we shall start discussing about the digital circuits. If we try to recall, in the last class we have talked about diodes, and we have seen that diodes are basically two terminal electrical device, and diodes are used to allow current to flow in one direction. So, we have also discussed about forward biased and reverse biased diodes. In continuation of that, let us first discuss about diodes, and we will see that diodes can be used as rectifiers. So, draw a schematic of the two terminal electrical device. Then we had seen that this is anode and this is cathode, and current flows from anode to cathode. That is what we have discussed in the previous class, and this is basically positive terminal and this is negative terminal, and we have also discussed that anode is essentially a p type semiconductor and cathode is n type semiconductor. So, that is what we have discussed. So, this is n type semiconductor and this is p type semiconductor. Okay. So, we will see today that these diodes can be used as rectifiers, and these rectifiers have applications in automotive system, essentially to supply DC current for battery charging. So, let us now consider that if the input is having or waveforms of the input signal, if it is sinusoidal. So, if the input signal, so this is the input signal, we can see that this input signal is having that positive and negative. So, this is positive, this is negative. So, this is input or supply signal in waveforms. And if we use a circuit, and in this circuit we will be having a power source. In this circuit we have an alternating source of voltage. So, this is alternating source of voltage, that is what we can see from the schematic, that this input signal has positive and negative halves, and then if we use a junction diode, and if we have a resistor. So, if we have a resistor, then say this is R L, and then if we try to draw the output waveforms. So, this is output signal in the form or in waveforms. Okay. So, this is the junction diode, and this junction diode is reverse biased. So, this junction diode is reverse biased. So, what we had seen from our earlier discussion, that reverse biased, that means forward bias. So, if anode is positive and cathode is negative, then only it will allow some current to flow. If it is that is forward bias. If anode is negative and cathode is positive, then there will be no current flow. So, that is reverse biased, and so resistance will be high. So, now what we can see from this that when forward bias, so when resistance is of high resistance, that I told you that when plus voltage is on cathode, then it is reverse biased. So, we have high voltage. So, in this case the junction diode is reverse bias. So, when the input signal is having positive, then only this will allow current to flow, and when the input signal the negative half, then no current will flow. So, essentially if we try to draw the output signal, then we will be getting like this. So, we will be getting only positive. So, try to understand, even if we have an alternating source of voltage, using this circuit, that is rectifier, we can have output which is having only positive components. That means, the input signal which is having positive and negative halves can be converted to only DC, that is positive halves, using this rectifier. So, converted DC signal. So, this is DC signal, and this signal is getting converted using this rectifier, and this particular circuit has applications in automotive system, especially to supply DC current for battery charging. That is what I told you. Okay. So, now let us move to discuss about transistors. You know that in our previous class we have discussed that diode and transistor, these two are important semiconductor devices, and these two devices have huge application in modern electronic system. And since in engine system we need to adhere with the electronic system for its better control and better operation, we shall be requiring transistors, diodes for collecting signals from different parts of the engine, to convert those signals or to amplify those signals to the analog unit, and essentially engine management system or engine control system will receive those analog inputs, and then there will be a digital circuit. So, analog to digital converter, ADC will be there, and eventually engine management system will give some feedback to those systems to have some adjustment, so that engine can be operated always at optimum level with better efficiency, lesser emission, all these things. So, now let us discuss about an important semiconductor device, that is junction transistor. Junction transistors. So, this is this junction rather transistors are very important device, and these devices have made significant development of electronic system in rather modern electronic system. So, I should say that this particular semiconductor device has huge potential for the development of small yet complex electronic system. So, these transistors are essentially again semiconductor devices, but these are 3 terminal semiconductor or electrical devices. So, these transistors are 3 terminal devices. Diodes are 2 terminal electrical devices, but transistors are 3 terminal electrical devices. These transistors are these transistors have manifold applications, essentially or rather typically for current amplification. Sometimes these transistors are also used as switch. We will discuss this part. Now, there are several advantages of this particular semiconductor device. What are those? Very small, then compact, then maintenance is not very stringent, and then of course efficiency is there and high performance. Second thing is that no moving parts, less power consumption, all these things. So, if I try to list down all these things, that these 3 terminal electrical devices typically used as current amplifier or as an electronic solid state switch or as an solid state switch. So, we will discuss if we need to use transistor as a current amplifier device or if we need to use this transistor as a solid state electronic switch. We will discuss this part. But as I said you, a few distinctive kind of features, or I should write advantages, are, as I told you, robust construction, no moving parts, then contacts, no moving parts or contacts needing maintenance, contact needing maintenance. Let me erase it. So, no moving parts or contact needing maintenance. Then we have negligible power consumption, small dimensions, small size. If it is, since these devices are of small sizes, lightweight. So, these devices are not bulky. So, all these advantages are there for these transistors. Now, let us look into the circuit of this transistor and their at least operational principle also. So, if we go to the next slide, if we try to draw this schematic. So, a semiconductor device and so this has 3 component or one semiconductor device. So, this is NPN. So, this is N, this is P, this is N. This is NPN, N type, P type and N type. So, these are basically material property, these are basically semiconductors are made from silicon typically, and the material property is something like that. I mean this is n type doping, p type doping and n type doping again. So, now you have studied all these things in your basic electronics course in undergraduate level. So, p type doping means these are having dominance in hole. So, holes are dominating in this p type while electrons are dominating in n type majority. So, when this is not that these 3 separate units are collected together to form this whole unit. So, this is a single unit itself, but the material property, material characteristics is such that this is n type doped, this is p type doped and this is again n type. So, this p type semiconductor basically in this particular case hole is dominating, while in this n type electrons are dominating. So, now when these two when this NPN type is there, then electrons will try to migrate from there will be then this junction will form, essentially there will be some sort of equilibrium. So, holes will migrate from p to n and n from electrons will migrate from n to p. So, basically there will be some migration of electrons will be there and an equilibrium condition will reach wherein there will be a band, a barrier. So, and until and unless that equilibrium state is achieved, that migration will take place. So, this is basically that is feature of this particular semiconductor device, material property, material characteristics, all these things. So, what you have understood that n type, p type or n type basically doped. So, holes are dominating and electrons are dominating. So, if these two are there, then migration of electrons and holes will be there, and this migration will continue until and unless an equilibrium situation is or state is achieved. When the equilibrium situation is achieved, that will be characterized by a band having some sort of basically band width or band kind of resistance. So, basically that that equilibrium state is achieved means there will be no sort of migration. So, this is NPN. Now, this transistors, as I said you transistors are 3 terminal devices. 3 terminals are base, emitter and collector. So, these 3 terminals are there. Now, this is base, and if we draw the circuit, this is emitter, right. So, now, so this is base, this is emitter, right. So, this is NPN transistor. So, this is NPN transistor. Similarly, it is possible to have PNP transistor. So, we have taken this example. Now, as I said you that even if you have this circuit, but external power battery. So, this barrier will be developed until and unless an equilibrium state is achieved. So, this until and unless this equilibrium state is achieved, no barrier will be there and migration of electrons and holes will be there. So, now the question is, when barrier is developed, even if we connect these two base and emitter current. So, basically that as if these 3 terminals devices can be regarded can be regarded as 2 diodes placed back to back. So, these 3 terminal devices can be regarded as 2 diodes are placed back to back. Now, let us draw a circuit of that. So, 2 diodes as if 2 diodes are placed, so this is P and NPN. So, as if 2 diodes are placed back to back. So, this is the schematic representation of this transistor, right, and we shall discuss all this later on. Now, as I said you that at the junction of P and N, a barrier will develop. Even if we connect this base and emitter using this circuit, some base current will flow, and these are basically diodes. So, this will allow current to flow in one direction. So, current will flow from base to emitter, because this base is positive with respect to this emitter. So, this is positive, this is negative. So, we know that current will flow from positive to negative. So, base is positive with respect to emitter, and current will flow even if we connect this base emitter with this circuit. So, a small current will flow IB through from base to emitter, but this current will not flow until and unless a small voltage, the cutoff voltage, that VBE, that is 0.7 volt, that is provided. So, that is the cutoff that we have studied in our basic electronics course. So, this 0.7 ohm is needed, that is for the, again this is for silicon semiconductor. So, 0.7 ohm is needed to break the barrier, to gap to open the gap. So, as I said you, a barrier will develop when equilibrium condition will be reached, and then to break that barrier we need 0.7 volt, then only a small current IB will flow from base to emitter, right. So, that is base current IB. So, this is IB is the base current. Okay. And as I said you, this 0.7 volt is needed, and that is also known as knee voltage. So, there is threshold 0.7 volt. So, that is this voltage is needed. Now, when this 0.7 volt, that is the minimum. So, that is a cutoff, this is also known as knee voltage. This is also known as knee voltage. Okay. Now, the moment when a small current will flow from base to emitter, if this is this transistor circuit, then in this transistor circuit what we can see now, that immediately this is collector current. So, this is collector C. So, this is collector C. So, a small current, the moment when small current will flow from base to emitter, that means if we have 0.7 volt, that is the cutoff voltage or knee voltage, that voltage will break the barrier and it will create a gateway, and then only a small current will flow from base to emitter. This small current will allow a significant amount of collector current to flow. If this circuit is, of course, this circuit is there, a significant amount of collector current to flow from collector to emitter, until and unless, because this is basically as I told you, this is these two diodes are placed back to back. So, current will flow from this base to emitter, but current cannot flow from base to collector, because this terminal is negative with respect to this collector terminal, from you can see from this particular battery arrangement. So, a few batteries are connected. So, though we can see that the B is negative, but this B is that the B is positive we can see, but this B is negative with respect to collector, right. If you look at this particular, that is B, so if you do not look at this part, then as if B is having positive terminal, but now the B is having negative, B is negative with respect to collector terminal, and the moment when a small current I V will flow from base to emitter, a small gap, a small opening area will be there, that 0.7 volt will break the barrier, and during that immediately a significant amount of collector current will flow from collector to emitter. In that case, B is acting, B is having negative, the B terminal is negative with respect to C terminal, C is positive. So, current cannot flow from B to C. So, that is why the current will flow from C to collector to emitter. That is the concept. Now, what we can see from this particular circuit is that under normal operating condition, current flows forward to the base to the emitter, but does not flow in the reverse direction. So, from current cannot flow from negative to positive. So, normal condition from base to emitter, small current will flow if the voltage is 0.7 volt or more, then only when the small gap is there, small opening area is there, that is the moment we break the barrier, significant amount of collector current will flow from collector to emitter, because this way it is not possible, because this will be negative with respect to collector, right. Now, what we can understand, that is very important, we are having kind of, so we are getting collector current with significant amount of collector current for a given or small amount of base current, and this is known as gain and indicated by beta. So, beta is gain. So, try to understand, if we have a small voltage which is equal or more than 0.7 volt, then we are getting significant amount of collector current which is as compared to small amount of base current, and this is known as beta or gain, and this is typically 100. So, we can see the collector current that we will get is 100 times of the base current. So, we can amplify the current using this semiconductor device. So, as I said you, this semiconductor device can be used as current amplifier or signal amplifier. Sometimes this is also used as solid state electronic switch, but in most of the cases typically this transistor is used to amplify the signal, which is very important. Now, question is, why do we need to study this particular solid state device or particular circuit electronic system in the context of this course? Try to understand, we have discussed about that in the context of engine system, we have engine management system or electronic control unit. This ECU or EMS will receive signals from several sensors. Now, the signal that will be received by the sensors is very small electrical voltage. So, very small voltage 0.05 volt like this. So, we need to amplify that, and to amplify that signal we need this circuit, so that the ECU or engine management system will receive very clear and proper information about what to do next, what will be the information to be provided to another systems, so that the engine can be operated always at its optimum condition. So, this is gain. Now, if we try to draw the equivalent circuit for this for example, then it will help us. So, if we try to draw this, So, schematically so this is emitter and this is C collector and this is base. So, this is IB, so this is VB and this is base. So, this entire is basically, let me erase this part, this is grounded. So, this is basically the schematic depiction of NPN type transistor, right. So, this you can see this is the base, then emitter, then collector. So, initially when this VB equal to 0.7 volt, then this IB will flow and then we will be getting IE, that is emitter current, right. And when this 0.7 volt is breaking the barrier, then we will be getting significant amount of collector current IC to flow. So, then we will be getting IC. So, we will be getting IC. So, we can write this IC, what we can write here, that IE equal to IB plus IC. So, eventually this is not kind of this is the schematic depiction, but these two terminals are also connected, right. So, essentially a small IB plus IC is giving, that is we will be getting current base to emitter and collected to emitter. So, base to emitter, that is IBE, collected to emitter, this is IC, that is the total emitter emitter to collector current. So, this is emitter IC plus IB. So, ICE, right. So, total current, essentially our objective is to have current amplification. So, the total current eventually will be base to emitter current plus collected to emitter current. So, in fact you can, it is confusing. So, just write that total current will flow from base to emitter and collected to emitter. So, this emitter is equal to base plus collector. So, current will flow to the emitter. So, it will come from base to emitter and collected to emitter. So, that is I is equal to IB plus IC. Now, we have already defined beta equal to IC plus IB. So, if we write here that IE equal to IB plus beta into IB, so that is IB into 1 plus beta. So, that means beta is the gain and which is typically 100, 10 to 100 even. So, if it is 100, then we can see that really we can, a small base to emitter current can be amplified using this transistor circuit. So, now question is, these transistors are operated, or these transistors can be operated in 3 different modes. One is known as cutoff, second is known as saturation, third is known as active or linear. So, if I write, so you can see that IC equal to beta into IB. So, this is linear relation. So, the total current that we will be getting, that is IC equal to beta into IB. So, this is linear. So, as I said you that transistors can be operated under 3 modes, this is 3 modes. So, right, and if we go to the next slide that we write. So, number 1 is active or linear regime, number 2 is cutoff, number 3 is saturation. Let me discuss about all these things, right. This cutoff and saturation, if we try to operate transistor, if we try to, so if we try to operate transistor in the as if we try to use transistor as electronic solid state switch, then certainly we need to operate transistor in these 2 regimes, and this is these 2 zones are responsible for switch. And this is the current amplifier. Right. So, now let me quickly discuss about what is this. So, either we can use transistor as electronic solid state switch, in that case we need to operate transistor in these 2 regimes, cutoff that is off, saturation this is on. If you need to use transistor for amplification of current or signal, then we need to operate transistor in this linear regime, and that is what we have discussed. Now, what is cutoff and what is saturation? So, let me tell you one thing, if this Vb is less than 0.7, then it is not possible to break the barrier that is already there between p and n type junction. So, this is p and n junction. So, in this junction the barrier that will develop for the when the migration will attain saturation state, if the voltage is less than 0.7, then it is not possible to break. So, this is totally off, the circuit is totally off, that is cut off. If it is 0.7, then a small current will flow base to emitter, and that small current will allow large collector current to flow from collector to emitter, because collector terminal is positive with respect to base terminal and current will flow from collector to emitter, and that is basically active or linear region, that is IC is equal to beta into IB. Now, so when this linear or active region is there, even if we try to, so there will be a limit, even if we try to increase this IB base current, if we try to increase IB base current, a small increment in IB will, rather beyond a certain value of IB, increase in IC will be very very small. So, that is called saturation. So, even if we try to increase IB, increase in IC will be very small or negligibly small, and that is the saturation, that is on as if. So, as if the transistor is between off and on, when on that means saturation state has reached. So, if we try to increase this voltage, then current will increase, IB will increase, that is base current, base to emitter current will increase. If base current reaches a threshold, beyond a threshold value of base current, collector current will not increase significantly, that is the saturation, that is on. When base current is 0, that is voltage across this base emitter junction is less than 0.7 volt, no current will flow, no base current, no collector current, that is off, that is switch on and off. But when base current is 0.7, beyond the threshold value of that base current, that is the current which will start flowing for 0.7 volt until that threshold value of base current, which is responsible for a small increase in conduction collector current, that regime is the active or linear regime. So, these transistors can be used as current amplification or signal amplification, and in that case we can use transistor as an amplifier. We also can use transistor as an electronic solid state switch. In that case transistor should run in these 2 regimes, that is cutoff and saturation. Okay, so, with this I stop my discussion today, and we shall continue our discussion in the next class. Thank you.